We're now looking at page 2 of the review. I'm hoping we can get through 2 pages on this video. This one is related to probability. So we're given a two-way table here representing data collected by a pet store based on the customers purchasing pet food and which flavor of those pet foods they like. So the first question is asking us to determine the percentage. Now this is asking us to round probabilities to 3 decimal places. I know that we've been writing them either as fractions or decimals or percentages, as long as we did so correctly and clearly. Just remember on Canvas, if it asks you a specific thing and you're entering one of those answers, it is looking for the specifically rounded decimal or fraction. So on this one, part A says determine the percentage of customers that purchase salt and vinegar spaniel chips. So if we look here, salt and vinegar is this third row down, and their spaniel crisps, I guess not chips, and that would be out of the total 60. So on this case, we are looking at 8 out of 60, which as a decimal would be 0.133. Or again, it asked for a percentage, so on this one we would probably write 13.3%. Part B, if one customer was selected at random, what is the probability, so now we're looking at probability, that the customer purchased bacon-flavored dog snacks. So if we come up to the top, we look for the bacon flavor. That's in the second row. Doesn't say anything else except they're bacon-flavored, so we're going to take 11. And again, it didn't restrict us in any way, so we put it out of the total. 11 out of 60, if we divide that in our calculator, gives us 0.183 as a decimal. Part C just asks how many customers purchased Woofy Crisps. So if we look up at the top, that first row, or I apologize, column right there, tells us that 18 of them purchased Woofy Crisps, so we would just say 18 customers. Then looking at the next one, if a Woofy Crisp customer was selected at random, so now we're specifically talking only about the Woofy Crisp customers, that's a tongue twister, what is the probability that he or she purchased cheese and onion flavored Woofy Crisps? So if we're looking at just Woofy Crisp customers, then we're again staying in this column right here. So when we're talking about probability, we are only going to be referring to those 18 customers, and then out of those, it says what's the probability they were cheese and onion flavored. So if we're looking at the cheese and onion in that column, then we're looking at these 7 right there. So when we're calculating this probability, that would be 7 out of 18, or approximately as a decimal 389. Again, determine the percentage of customers that purchased Big Dog Crisps. So again, we just come up to the top, we find how many purchased Big Dog Crisps. It doesn't restrict us in any way, so that again is out of the total. That's what we want to practice here with these, just making sure that we can tell when it is calculating out of the total or restricting us to a specific part. F says if a customer was selected at random, determine the probability the customer did not purchase cheese and onion flavored snacks. So if we look up here, it looks like if we're looking at who did purchase cheese and onion, that would be these 24. So those that did not would be these 11 and these 25. So if we add 11 and 25 together, it looks like there are 36 people that did not out of the total 60. Again, as a decimal, that's 0.6. It asked for a percentage, so we would say that would be 60% of the customers did not purchase those. Moving on to 14. 14, again, probability related, however, to a tree diagram. The tree diagram that is given has the probabilities listed on it. You were asked to kind of pull apart the tree diagram going backwards. So we went forward a lot with these. Can we understand what we're looking at going backwards? So part A says, given the title, each set of branches, okay, that should say of, each set of branches, describe the events that are taking place. You'll notice the title here on the first event or set of branches is first card and the next one is second card. That would imply that cards are being drawn. So we are looking at 2 cards are being drawn. That's what we can tell from the title. When we look a little bit deeper, you can tell that the options or the outcomes here are red or blue. So we know that there are only red or blue cards within this group that we're drawing from. It asks how many initial cards were there. Well, if we look at the first event that happens before they draw the first card, it looks like the probability is 7 out of 10 or 3 out of 10. So that implies that there must be 10 cards initially that were being drawn from. Part C asks how many blue cards were there initially. So again, if we look at the blue, it looks like there were 3 out of the 10 must have been blue. So we would say that there were 3 cards there. Moving on to the next one, it says after one card is selected, is it replaced before another is drawn? Now again, if we look at the tree diagram, this allows us to pull this apart just a little bit. You'll notice that if you drew a blue on the first one, and then your next draw is also a blue, the number of cards goes down. If you look at that, that's 2 out of 9, implying that you drew a blue already. That would need to stay a 10 if we were putting it back, and it would need to stay 3 out of 10 actually. So we can tell that no, right, there's one less card in the second draw. E says determine the probability that you end up with 2 blue cards. So the probability we're looking at there with 2 blue cards would take us down this blue-blue branch. So blue-blue. And remember, when you go down a branch, you multiply the probabilities. So we're going to take 3/10, and we're going to multiply that by the 2/9 to get to the end of that branch. So we would say 3/10 multiplied by 2/9. And again, we can just plug that in. If we were going to round this one didn't specify, that would be about 0.067, or if you'd like to write it as a percentage, 6.7%. So anyway, it's fine. The last one, determine the probability you draw at least one red card. So in this case, we are looking at branches that give us red cards, but only at least one red card. So either red, red. This one gives us at least one, but actually 2. So that would say this branch, 7/10 and 6/9. Or we could get a red and then a blue. That's still at least one red. So if I go down that branch, that's 7/10 times that 3/9. Or we could get a blue first and then get a red, which also gives us at least one red card. So it's everything but the blue-blue. And if we calculate that, we just plug that in, that would give us 9.33. Or again, if you want to write it as a percentage, 93.3%. So it's highly likely that you're going to get at least one red card, given there's 7 instead of the 3 blue. Okay, I'm only going to do one page again on this video, and then we'll continue on to the next one.